Hey Wheaton North, let's do a follow-up to Lab 1 in our calorimetry unit. This video will focus on the calculations related to the lab. Specifically, negative Q is equal to positive Q. So in order to understand this phenomenon, we have to remember that the heat lost by one substance is the heat gained by another substance. We're representing that with the variable Q. The heat or the energy lost, negative Q, is equal to the heat or the thermal energy gained, positive Q. If that heat lost is equal to the heat gained, therefore, we can set our equation to negative MC delta T is equal to a positive MC delta T. When you look at a problem, go ahead and write out this equation, and then underneath it, split your page, keeping track of which substance is losing the heat, or what will be your negative Q, and which substance will be your positive Q. In this case from our lab, we know the metal, we heated it up, and it was going to lose heat, and the water was going to gain heat, or increase in temperature. All right, so we've got our variables divided. We've got our metal on the left and our water on the right. And then we annotate that with the specific variables we're looking for. So now we've divided our page so we can keep track of which numbers are going where, so we can eventually solve for the variable that is unknown. In this case, we're trying to figure out the identity of the unknown metal, which is the specific heat. Recall that the specific heat capacity is a unique and innate property to the metal. So once we solve for C, we can compare that with a reference table to identify the metal. So let's take a look at a problem. Go ahead and pause the video to write it down. Okay, once you've written the problem down, the steps you need to follow are listed here in bold. So we've got a scenario walking us through similar to what we did yesterday in the lab. So we've massed the unknown metal at 6.43 grams, and we've heated it in a hot water bath. We took the temperature of the hot water bath at 100 degrees Celsius. The water in the hot water bath is the proxy to identify the temperature of the metal. The temperature of the metal is 100 degrees Celsius. We then set up a calorimeter with a known amount of water. In this case, in this problem, it's 25 milliliters. Recall that 1 milliliter of water is equal to 1 gram. We placed the 25 milliliters of water in the calorimeter with a thermometer and then measured the temperature of the cold water in the calorimeter. In this case, we measured it at 23 degrees C. Once we recorded these values yesterday, we then placed the hot metal into the calorimeter, put the lid on top, and watched the temperature of the system increase. When the temperature reached its maximum, in this example, it was 27 degrees. So now we have to identify the specific heat capacity of the unknown metal. So the steps: list the formula that you need. We're listing and organizing the variables. We're solving and then identifying the metal. So here we've listed our equation at the top. We've divided our page in half. We know that our negative Q is what lost energy, and our positive Q is what gained energy. We know the metal lost energy, the water gained energy. Okay. You should be able to now list your M1 or your M metal, your C1 or your C metal, and your delta T or your delta T metal on the left, and then listing those variables on the right. On your page, just to double check, you should have that the mass of the metal, so M metal, should be equal to 6.43 grams. The C of the metal is unknown, or your X, and the delta T of the metal is 100 minus 27. And you should have calculated what that delta T of the metal is on the left. On the right side where you've listed your variables, double check your answer. You should have the M of the water, 25 milliliters or 25 grams in this case. The specific heat of the water, which we know from our reference table, is 4.18 joules per gram degrees Celsius. And finally, the delta T of the water, which in this case is 23 minus 27. we see the cold water change by, or increase by 4 degrees Celsius. Okay, once we've listed those variables out, we then need to solve for the specific heat of the metal. How are we going to do that? We are going to unmultiply the mass and the delta T of the metal from this side. How do we do that? We divide. When we divide the M of the metal and the delta T of the metal from this side, it cancels out, but we have to do that to this side. So to solve for the answer, which is given at the bottom, you're taking the mass of the water times the specific heat capacity of water times delta T of the water. You're dividing that by the mass of the metal times delta T of the metal. Okay, the answer you should have gotten in your notes is listed at the bottom. If you look at a specific heat capacity reference table as given in the lab, we know that that metal should be aluminum. Let's take a look at another sample problem. Go ahead and look at the problem, pause the video, and see if you can solve for the correct answer. Now in this case, we've color-coded the variables to help you see where they belong. So you should have listed out your two equations and given yourself a place to write out or identify all of your variables. So we know that the mass of the metal, or the variables related to our negative Q, are listed in red, and those related to our positive Q are listed in green. Our metal is 6.43 grams. We are trying to solve for the specific heat of the metal so we can identify it. We know the temperature changed or increased from 27 to 100 degrees. Okay, make sure you subtract those out ultimately so when you sub them in, it's a little easier. Now let's identify the variables for our positive Q, or our cold substance. We have 25 grams, our specific heat of water, which is known, and our delta T of water. We know the water increased from 27 to 23. We subtract that, and it's 4 degrees. Again, we're solving for our unknown. How do we do that? We're trying to solve for C1. Right now it's multiplied by M1 and delta T1. We need to unmultiply it. How do we do that? We divide. So we're going to divide this side by M1 and delta T1. But if we do that, we have to divide this side by M1 and delta T1. When we do that, we're left with C1 is equal to M2 C2 delta T2 divided by M1 delta T1. That will leave C1 by itself, or we're solving for the unknown. Okay, here we can see that. We're solving, or we're solving for C. And the answer you should have gotten is 0.89 joules per gram degree Celsius. So if we compare that on a reference table, we can identify this particular metal as aluminum. Okay, here's one last question for you. This is very much, the practice questions are just like the lab, which I will be collecting. It's also a lot like the practice given in worksheet 4. Make sure you take a look at these practice problems so that you're prepared to solve for an unknown variable. So go ahead and pause the video, write down the problem, and see if you can solve for the correct answer. All right, if we take a look, oops, let me go back. Okay, go ahead and see if you can solve for that final answer. And make sure when you do worksheet 4 for additional practice that you check your answers. Okay, worksheet 4, here are some of the answers. The answer keys are also posted online. Please work with a neighbor. Please go to resource if needed. Please ask lots of questions. It gets easier with practice, and I know you can do it. Have a great day, Wheaton North.